Okay, hello everyone. Today we will do a lab for layer 2 networking using AC and Feed AP together. And firstly, let's see the background of this lab. A company with a large area is building an office network. To provide better user experience, the company uses the AC and Feed AP networking mode and adds the AC and AP to the same layer 2 network. As a network engineer, you need to complete device configuration to provide wireless network services for employees. And we hope that after finishing this lab, you will be able to understand the working principle of this networking mode and to get familiar with the configuration of this networking mode. Then let's see the topology here. In this topology, we have two switches. This one works as egress device, and except that the other switch works as a layer 3 switch, which is connected with AC and APs. And in this figure, you can also see some parameters. For example, the port trunk or the IP address of the SVI interface, right? And the SSID, so on. Then let's see the lab requirements. The IP network segment between the layer 3 switch and the egress gateway is 192.168.30.0. Mask length is 24. Actually, as you can see here, is a segment between these two devices, and the WLAN 30 is used to act as interconnection WLAN here. And the gateway address of the layer 3 switch is 192.168.30.254. Mask length 24 is uh, SVI interface for WLAN 30 on the layer 3 switch. And about the DHCP server, in this lab, the layer 3 switch serves as the DHCP server of the APs and assign IP address to the AP. Then AC serves as the DHCP server of user and assign IP addresses to the users. Then it's about the AC management. The management VLAN is VLAN 10. IP address is 192.168.10.3. This is the IP address on the AC. And the AC is connected to the laser switch in bypass mode. You can see here, AC is connected with this switch, and this mode is called bypass mode. Except the bypass mode, another mode is in-pass mode. In-pass mode means, for example, AC is connected between the egress and the layer 3 switch. Okay, and then let's go. The source address used by the AC to establish control and provisioning of wireless access points terminal with the AP belongs to VLAN 10, and actually is address here 10.3. And layer 2 networking is used for the AP and AC. Okay, next for the AP management. Management VLAN is VLAN 10, and segment is 192.168.10.0, and gateway is 10.1. For all the users, they are in VLAN 20, and this network segment is 192.168.20.0, mask length 24. The gateway is 20.3, and the centralized forwarding mode is used here. Centralized forwarding means that all the traffic of the clients should go through AC. So the traffic should be sent to AP, AP will send it to AC through the CAPAP terminal, and AC will send it to the egress based on the routing entries. So actually from here, we know that in this lab, we should have some routing entries, and later we will see how to configure them. Okay. And except that the wireless network is a Wi-Fi network which name is start, and the password is Ruijie at 123. Okay, here are all the lab requirements. And to satisfy these requirements, here it's using us some configuration ideas. The configuration can be divided into 8 steps. Configure the management VLAN and the service VLAN on their three switch. Configure an adjust port for the AP on the layer 3 switch. Configure static route to the AC on the layer 3 switch. Configure the address for interconnection to the egress gateway on the layer 3 switch. Configure management VLAN on the AC. Configure AP access information on the AC. Basic information configuration on the AC, and the configuration of egress. This is configuration ideas. So following this idea, next we will do the configuration together. And to finish this lab, we will use console port on the equipment to configure. And the tool we will use is PuTTY. And of course, you can use the tools you are familiar with. For example, you can use Secure CRT, you can use Xshell, and so on. And here we will use PuTTY. Since we are using the console port, so firstly, we should know which COM port we're using right now, right? After connect your PC with the equipment, then let's check which COM port we're using. And let's see how to check it. In your system, you can search Device Manager. And about the Device Manager, let's find here ports. And in the ports, you can see the USB serial port is associated with COM5. So in PuTTY, firstly, we choose the connection type, we choose serial, and the serial line is COM5. Okay, the speed is 9,600. You don't need to change it. After that, click Open. After clicking Open, you could see a page like this. So just enter. As you can see here, we have logged into a device which name is Ruijie, right? Which name is Ruijie. And as you can see here in the configuration ideas, what we're going to configure first is a layer 3 switch. So actually, the device we're logging in is a layer 3 switch. So how about this? Let's change the name of it first. We call it a layer 3 switch. Okay, by using the command hostname L3 switch, we can change the name of this device. Okay, and then following the guidance here, create the planned management VLAN and the service VLAN. The management VLAN is VLAN 10 because all the APs belong to VLAN 10. Okay, so let's create VLAN 10 by using the command VLAN 10 and enter. Okay, so in this way we have created VLAN 10, and if you need to confirm it, so you can use command show VLAN to check. You can see we have created VLAN 10, right? Okay, and actually on the layer 3 switch, in this topology, you can see on this switch, layer 3 switch, do we need to create VLAN 20? You can think about it. VLAN 20 is a service VLAN, or the user traffic belongs to VLAN 20. But actually, since we're using centralized forwarding mode, so all the traffic will be sent to AP, and AP will send it to AC through the CAPRAP terminal. And then, after receiving that, AC will send the traffic to the destination through the layer 3 or through the routing information. So actually, on this layer 3 switch, we don't need VLAN 20 at all. Okay, so this is the reason here why we do not create VLAN 20 on this switch. Okay, and then next, enter the configuration mode of the physical interface connected to the AP. Switch the link of the interface to the trunk mode, and set the default VLAN of the interface to management VLAN of APs. And here, let's see, on the layer 3 switch, the interface which is connected with AP is G07, so firstly. So on this device, interface G07. And first change the mode, so switch port mode trunk. And since it's connected with the AP, so we should set the default VLAN of this interface. And the AP belongs to VLAN 10, so here switch port trunk native VLAN 10. Okay, and in this way we have changed the default VLAN of this interface to be VLAN 10. And then next step, enter the configuration mode of the physical interface connected to the AC. And first, let's find the port in the figure is here. We use G01 to connect with the AC. So let's exit interface G01 and switch the link of the interface to be trunk. Okay, so the command is switch port mode trunk. Okay, and this is about the configuration of the interface, which is connected with AP and AC. And then let's go on. Since the layer 3 switch will serve as the DHCP server of all the APs, so next step would be the configuration of a DHCP. And let's see what we should do. First, configure an address port for AP on the layer 3 switch. Okay. About the IP ports, we should just enable the DHCP service first. Service DHCP. By using this command, we have already enabled the DHCP service. And then, since the layer 3 switch will work as a gateway, so and the gateway is VLAN 10, so interface VLAN 10, we have created a SVI interface for VLAN 10. And the IP address, as we can see in the figure, is 192.168.10.1. So IP address 192.168.10.1, and the mask is 255.255.255.0. Okay, this is the configuration of the SVI. And next is configuration of the IP port. And let's see the requirements. It's right here in the document. Create the DHCP address port, which name is AP port, to assign IP addresses to the AP. In the address port, the network segment is 192.168.10.0, mask length is 24. Gateway is 192.168.10.1. And the IP address used by the AC to establish a cap-up terminal with AP is 192.168.10.3. This is very important because in a wireless network, AP should establish a cap-up terminal with AC. Right? It's what we have introduced in the theoretical part. And to establish the terminal, all the APs should know the address of AC. And how do we make them know that? By using this command, DHCP option 138. We can tell all the APs that the AC's address is 192.168.10.3. Okay, so let's do this step. First, the IP DHCP port, and the next part will be the name, so AP port. From the name, we can know this IP address port for all the APs. Enter. After creating the IP port, firstly, we should limit the range. Since the segment is 192.168.10.0, and the mask is 255.255.255.0. And then the default router or the gateway of all the APs is 192.168.10.1. So the command is default router 192.168.10.1. Okay, and the next to all the APs, IP of AC. So option 138, which IP is 192.168.10.3. Okay, so until now we have finished the configuration of the DHCP on the layer 3 switch. And then configure static route to the AC on the layer 3 switch. Configure static route to the user network segment. And the next hop is 10.3. From this figure, we can find 192.168.10.3 is SVI 10 on AC. Okay, let's do it. IP route 192.168.20.0 must, and the next hop is 192.168.10.3. Okay. So until now, we have finished the configuration of the static routes. And of course, the configuration of static routes could have some more optional parameters. For example, the first step is destination and then mask. And here, what we use is next hop. Of course, you can use outbound interface as the third part. For example, G01, G02, and so on. Just the outbound interface in your scenario. Okay, then let's go. Configure the address for interconnection to the egress on the layer 3 switch. So from the figure you can find when it comes to the connection between the egress and the layer 3 switch. And the configuration here is similar to that between the AC and layer 3 switch. So firstly, find the physical interface, which is G05, and then change the mode to be trunk. So switch port mode trunk. And then next on the layer 3 switch, since it's switch, so we cannot directly configure the IP address on the physical interface. But between the layer 3 switch and the egress, we need the interconnection address. So here what we use is WLAN 30 to be the interconnection WLAN. Okay, so on the layer 3 switch, we should create WLAN 30, and for the WLAN 30, interface WLAN 30, we should create SVI and configure the IP address of the SVI here. In the figure, we can find the SVI 30 on the layer 3 switch is 192.168.30.1. So IP address 192.168.30.1. Mask length is 24. Okay, so we have finished the configuration on this side, on the layer 3 switch side. And next, let's see, configure the default route to the egress gateway with the next hop is 30.254. Because all the traffic should go to the egress. And this is actually between the egress and the layer 3 switch is a layer 3 network. All the traffic forwarding is based on the routing information. And since the topology is simple, we don't need to run dynamic routing protocol, for example, OSPF or, for example, RIP and so on. So here what we use is a static route. And let's see. What we are configuring here is a spatial static route. It's a default route. Why we call it a default route? Because no matter the destination or the mask is 0. So let's do it. IP route static 0.0.0.0 and the mask is 0.0.0.0. And then next hop would be the egress. And the interconnection segment here is 192.168.30.0. And on the other side, from the figure, the SVI 30 on the egress is 30.254. So the next hop is 192.168.30.254. Okay, and we have finished the configuration of this default route. And here, I think some of you could get confused. Why we should 0.0.0.0 here? And what it represents? Because normally, if we use, for example, this route, IP route 192.168.20.0, we can know that, okay, the destination network is 192.168.20.0, mask length is 24. This is the destination network. So if we use a default route, what's the destination? Actually, it means any. If you use default route, means the destination is any. And so we can know that the function of this static route is that no matter what's your destination, right? No matter what's your destination, once I receive it, I will directly send it to 192.168.30.254. Means no matter what's your destination, I will directly send it to the egress. So all the traffic will be guided to the egress device. Okay. Until now, we have finished the configurations should be done on the layer 3 switch. And don't forget to save the configurations. The command is write. Okay. And we should exit and then write. Okay. After seeing this means what you have done has been saved. Okay, after finishing the configuration of the layer 3 switch, then would be that of the AC. So let's see what we should do on the AC. And since here, what we're using is a console port on the device. So actually, now I need to disconnect the console cable with the layer 3 switch and then connect with AC. Okay, and then press enter. You can see that the device name used to be layer 3 switch, but now it's Ruijie, right? It means we have connected to another device and it's AC. Okay, so and enter the configuration view, and as usual, let's change the name, host name to be AC. Okay, now the name of this device is AC, and in this way you can figure out that what we are configuring now is AC. Okay, let's see what we should do on the AC. Okay, here is you can see on the CLI, here is a notice. It's asking us the CAPREP no IP address. So it's asking us to configure the IP address for the CAPREP. Okay, this is a very important command, and later we will do it. Okay, here we let's ignore this notice or this alarm. Okay, and following the lab guide, let's see. Firstly, what we should do is to create a VLAN on the AC. And on the VLAN, on the AC, we should create a VLAN 10, because this is a management VLAN of the APs. Okay, and for the VLAN 10, we should create a SVI, right? And from the figure, we can know that the VLAN is SVI address is 192.168.10.3, so IP address. Okay, and then the physical ports connected with layer 3 should change the switch port mode. And so interface G01 switch port mode chunk. Since it's a CMS, what we have done on the switch, so let's do it quickly. Okay, and then, which is important, configure the AP access information on the AC. Set the source address of establishing a camp terminal with AP, which is 192.168.10.3. This is very important, and the IP address we use here should be the same as what we have configured on the layer 3 switch. I think you still remember, right? When we config the IP address port, we have used the command option 139 IP, and the following address is the same as here, right? 192.168.10.3. So let's do it. AC controller, and we have entered the view and the camp control IP. CTRL means control. Control IP is 192.168.10.3. Enter. Okay. And after using this command, you will find that this notice or this alarm will not appear again. Okay. So then let's go. Configure a default route with net hop 192.168.10.1. Let's see. Let's do it first. Okay. IP route 0.0. Sorry. Next hop 192.1.10.1. Okay. Firstly, let's see it. IP route 0.0.0.0 and mask is 0.0.0.0. So these are default routes. And the next hop 192.168.10.1. So the means that after receiving any packets, AC will forward it to the layer 3 switch. And I think you still remember that on the layer 3 switch, we have configured the default route, right? It's guiding all the traffic to the egress. So the data forwarding would be like this. AP will send the traffic to the AC through camp terminal, and after receiving that, AC will use this default route, send the packet to the layer 3 switch, and layer 3 switch will send the packet to the egress. Okay, this is a data forwarding process. Okay, and then next, since except managing all the APs, AC will serve as the DHCP server of all the clients, because client 1, client 2, all the users in this network should get their IP address, and the DHCP server is AC. So let's configure the DHCP service on the AC. First command is to create VLAN first. Pay attention here. First is to create VLAN, because all the users belongs to VLAN 20. So let's create VLAN 20. And of course, we should create a SVI 20 interface VLAN 20. The IP address is 192.168.20.1. Okay, and the mask length is 24. This would be the gateway of all the users or the clients. And after that is a configuration of DHCP. First, they enable DHCP service, and then create a DHCP port, IP DHCP port. The name is STA port. Okay, and the network, then IP address range will be 120.0. Since it's similar to what we have done on the layer 3 switch, so let's do it quickly. Default router. Sorry. And the DNS server 114. Okay, this is what we have got from the from this document, right? The network segment, the DNS server address, the gateway address. So we should set them in the configuration. And then, let's see, finishing the basic configuration. Next will be the configuration of the WLAN. Okay, so let's see what we should do. First, they set the name of the Wi-Fi network to staff. So first, this is the name of the Wi-Fi, or you can think it's a SSID. Okay, it's also called SSID of this network. And keep the default forwarding mode. By default, what we use is a centralized forwarding mode. So let's see what we should do. Firstly, WLAN config 1 staff. So after using this command, we have set the SSID of WLAN1 to be staff. Okay, and then configure the mapping between the WLAN ID and the VLAN ID in the default AP group. So let's see. Create a AP group first. So AP group, the name is default. Of course, you can change the name. For example, AP group staff, or AP group office, and so on. The name should be changed. And then specify the mapping, interface mapping 120. Here are two numbers. One means WLAN1, the WLAN we have just created, which SSID is staff, okay? WLAN1, and its VLAN is 20. So we have mapping the WLAN1 with VLAN 20, okay? Enter, and end. Okay, this is a configuration of WLAN1. And what we should do is to see the configuration what we have done on the AC. Because until now, we have finished the basic configuration of AC. Okay, and then let's go. Configure the egress gateway. So we should connect to another device. Connect to the egress here. Okay. And at this time, I need to disconnect the console cable with AC and connect with the egress device. Okay, I have connected to it, and you can see here is Ruijie, right? The name is Ruijie. So as usual, we will change the name first. Right? Host name, for example, we call it egress. Okay, and for the egress device, let's see what we should do. First, they enter the configuration mode of the physical interface connected to layer 3 switch. Okay, since it's 05, so it's interface 05, switch port mode trunk. And since the interconnection VLAN is 30, so interface VLAN 30, and VLAN 30 does not exist, so we should create the VLAN 30 first, right? VLAN 30 and the interface VLAN 30 and the IP address 30.54.24. Okay, this is a configuration of the interconnection device, and then is a configuration of the route to the intranet. Okay, let's see what. First, the route is one IP route static 192.168.10.0. Another is 20.0. Okay, and let's see these two commands. The first is that IP route 192.168.10.0. The destination is 192.168.10.0. And the next hop is 30.1, means if we have sent some packets to, for example, to the network in this figure, and of course there will be some feedback. And if the packet to the intranet, which destination belongs to this segment, belongs to 192.168.10.0, this segment, so egress will send it to the layer 0 switch because the next hop is 30.1. And of course, if the destination segment is 192.168.20.0, which are the clients. It's the same. Egress will send the packet to the layer 3 switch, right? Which next hop address is 192.168.30.1. Okay, so this is about the configuration of egress. It's quite easy to understand, right? Okay, and then let's see. Next, enable WPA2 PSK authentication and set the password of the Wi-Fi network to Ruijie at 123. Because until we have finished the configuration of egress, actually all the APs are online and they have already set out the signals. Okay, and the next step is enable the WPA2 PSK authentication and set the password of the Wi-Fi network to Ruijie at 123. The reason why I put it to be the next step is that if you have finished all the former steps until step 8, actually the APs are already online and it can already provide the network service for the users. We can test it. Now use my laptop. You can find, okay, this is, you can see here, this is WLAN, and the name is stuff. It's what we have just configured. But from this logo here, you can see it's not blocked. The others are all blocked, but this is not, because you can see it's open. The reason is that we did not enable the authentication function during the configuration, right? And we can try to connect to it. Okay, and once we connect to this, on the CLI, you can see here are some information. You can see this is a client, which is attached to the AP, right? This is my laptop. And let's see the result here. Actually, the system has automatically disconnected from this Wi-Fi because actually in the real device only have the egress, the switch, and the AC, and I did not connect them to the internet. So even I connect to the Wi-Fi, I cannot access the internet, and the system automatically disconnect from the Wi-Fi. Okay, but you can find it's already works, right? You can successfully set out signals, and users can find it, can scan this signal, but it's open. And to solve this problem, since it's open, it's not secure, so we need to enable some authentication functions on it. Okay, let's do it. All the AC and config WLAN SIG 1. So this is a WLAN security profile, which is sourcing with 1. And then security WPA enable. So we have enabled WPA on it. And security WPA ciphers AES enable. So we are using AES to encrypt, right? To encrypt. And then security WPA AKM PSK enable. Okay, and the security RSN enable. Security RSN ciphers AES enable. Security RSN AKM PSK enable. And security WPA AKM PSK set key ASCO Ruijie at 123, and security RSN AKM. Okay, this is a configuration in this state. And actually, from this command, you can find what we have done are WPA and RSN, right? Two types. We have enabled these two types at the same time. And even for the, you can see here, even for the password, we have set them to be the same, right? Which is Ruijie and at 123. Okay, and after configuring this, of course, we should save the configuration. So, right. Okay, and then let's check. And here you can find the SSID is the same stuff, and right now it's blocked. Right? If you want to connect, you should enter the password, which we have set to be Ruijie at 123. Right? And on the AC, you can also check show AP config summary. So you can check all the AP status. You can see that the AP's name is here. The IP address is 10.2. The MAC address, the radio, and how long it has been online, and the state is run. Right? Means it's running normally. And here, as we have just said, you can use your own laptop or use your own mobile to test if we can receive the signal and if we can access this wireless network. And if you can successfully connect to it, you can also check the IP address you have got. If it's in the network segment you have configured, which is 192.168.28.2, right? Okay, this is about the configuration of the layer 2 networking by using AC and FIT AP to build a wireless network. Okay, that's all for this lab.